forces and their action. Here, even the energy involved with the applied force will also come into picture. That's what the work, power, energy, the name of chapter is mentioned here. So let's basically, let me introduce with an example. So I'll keep a block of mass M. Initially it is a test. So what are the forces acting? N, and this is mg. Here I'll apply force F. Then it starts accelerating, we know. And after some time, the block is here. The block is here. So the force will be continuously acting. So this is at t equal to 0. And it has covered, it has undergone a displacement S. And after some time t, it is here. And because of acceleration, it will acquire the velocity. So in general, what is acceleration? We know F by m. Then velocity is equal to, we write at. Or in terms of the distance covered, all any of the formula, ft by m. Okay, this is the speed of the block, and it'll cover the distance as that one. Now look at I'll define kinetic energy. So what is the basic definition of kinetic energy? Energy possessed by a body by virtue of motion. Energy possessed by a body by virtue of its motion. And how much kinetic energy is equal to? mv square by 2. If body is at rest, velocity is 0, body is in motion, velocity non-zero. So what all that energy is due to motion, that one. And that kinetic energy, and the unit for this will be joule. Already you know that. Or in terms of symbol, it will be J. So like this, we define the kinetic energy. Now look at this. Here kinetic energy, initially it was a test. So what is the initial kinetic energy? 0. What about final kinetic energy? mv square by 2. Now from where this particular body got that kinetic energy? The applied force. So this applied force, what all the force what I'm applying, so what is doing? It is what supplying energy to the block. No? Got this? It is what supplying energy. Sir, how come that one? So look at this. What is this applied force? Myself, I'm pulling the block. Myself, I'm pulling the block. So as I start pulling the block, what happens? Kinetic energy of this increases. I'm pulling the block means what I'm doing here? Actually, I'm having energy, what you can call muscle energy, that one. I'm having energy in the form of chemical energy in my muscles. Got it, that one? So now that my muscle energy or my mechanical work in the muscle energy is given to the block. So is it any transformation of energy is occurring? Yes, it is. So the energy in my body now is going to the block. Sir, I am not going to see it. I think the transfer mechanism occurs, no? The block is at rest, 0 kinetic energy. Now it's in motion, it's possessing kinetic energy. This energy for the block, from where it came? By the external agent. So here I'll bring that person into the picture so that you'll come to know that as this person is what? Is pulling this particular block. Or I'll is pulling the block. So the person, I'll give push. It'll be easy for you. Now this push, from where it has come? It is due to the person. Okay, now from where this particular energy for the block has come? Due to the person. So what actually here the mechanism is going on? The energy from the person, mechanical energy, the energy in the form of chemical energy in the form is, or the chemical so energy in the form of chemical is stored in the muscle. That energy what will be given to the block. This overall process it takes place here. So therefore, shall I say that the person is doing work. I'm introducing the idea of the work done. So the person does work here, and because of that, what happens? The body or the block as changing. There's a change in kinetic energy of the block. So I can say no, this person did work on the block. Because of that, what happened? The kinetic energy of block has changed here. So what is the one immediate impact you can see work done? So when work is done, there'll be change in kinetic energy of system. Means like which all forces are doing work: weight, N, mg, normal contact, mg, and applied force. All three are acting. Yes, the push force exerted by the person is what it does work. Then, so here, so what is the basic definition? So work done equal to the basic definitions show that work done equal to force force into displacement. And displacement of what? Displacement of point of application of force. So there's a work done, a bar dot mathematically. I'll bring like this. And look at this dot product of two vectors. What you get? Scalar. So work done is a scalar or a vector quantity. It's a scalar quantity. So will you say that I did 10 joules of work along north while washing clothes? Then like to shift the like a cot, I did 15 joules along northeast. Nothing. No, we just say we did work because the it doesn't have any direction. So therefore, work done is a scalar quantity, and there's a dot product. And further, if you expand this, we'll get Fs cos theta. What is theta? Angle between F bar and S bar. F bar and S bar. 15th, 18th, you are supposed to work out. Already I discussed that concept, no? Anything new I should discuss, but already the thing which is there in note, the same thing is being asked. Check my notes once. It's available 15, 18. So angle between F bar and S bar, that one. So there's a thing. So now all doing work. So then any force acting on the block should do work. No, look at that one. What is F? F is the force acting. So it's undergone displacement. Look at N. N is also acting and the block undergone displacement. Look at the angle between N bar and S, 90 degree. And work done by the normal contact should be 0. So here, why there is no work done by the normal contact? So we write N bar dot S bar. N into S. N is non-zero. Cos of 90 will be 0. Work done by the weight. Mg bar dot S bar. Mg cos 90. That is also equal 0. So who did work? Only the applied force. Okay, now what we notice change, there was change in kinetic energy of system. So definitely this work done and kinetic energy, they are somewhere related. Somehow they're related. So that relationship I'm trying to find out now. Wait for key correction, no problem. Question number 8, wait for key correction. A point of application of force, that one. So point of application of force. So what is the, what do you mean by point of application of force is not constant? I don't know that sentence. Somebody, Lokesh, you are asking something. Point of application of force is not constant. There's a displacement is there, no? If it is changing with the time, then I'll apply the variable accelerated motion, then I'll find out all other things. That's all, no? Just I'll go back to the laws of motion. If a time varying force acts, then we can manage. So this is about the the basic idea of the work done. So now we know that F is equal to ma. So further m, what you a you can write it as v dv by ds. F into ds equal to mv dv. I'll integrate 0 to s. This should be, and this is equal to uv. This everything is what? The work done. Force, let it be function of distance. We can manage here. So let me assume time being, the force, if the constant, you write f into integral ds. If f is a function of s, then you are going to substitute, then you are going to integrate. For any force, we can find out the work done. It's not that this should be the only nature of force. Any type of force, when it's acting on an object, and if the point of application of force undergoes displacement, it is said to do work. So this should be equal to v square by 2 m by 2 v square minus u square. So this should be equal to mv square by 2 minus mu square by 2. So this you write it in kf minus ki. I'll better write it. Any condition for work done by which force? Work done by any force. This is something very important. There's nothing called like a conservative force, non-conservative force, radial force, tangent, any force. Work done by any force is equal to what? Change in kinetic energy of system. This is called like a work energy theorem. I'll put it in books. They'll just put it like this. This is called as work energy theorem. And this is going to help you a lot than conservation of mechanical energy. I'm telling this one. Work done by any force is equal to change in kinetic. You need not to bother any force, sir, pseudo force, sir, like it's a tangential force, or there's nothing called like any limitation for this. So work energy theorem can be applied in inertial frame S. Work energy theorem can be applied in non-inertial frame S. Work done by any force is what equal to change in kinetic energy of system. This is called like a work energy theorem. So there's no limit for the nature of force. Sir, time varying force, constant force, the force varies with the distance goes, the force varies with the speed, and then also the work done equal to change in kinetic energy. What all forces are acting. So from that here, so I know work done by normal contact 0, work done by weight 0, work done by applied force non-zero. So therefore that force is what responsible for change in kinetic energy of system. So here in this chapter, what we are going to relate, like how that energy from person or the from agent who is applying, how what will happen, it will get manifested in the system. I think this is the very important here, because the person is going to supply energy. Now what all he supplies energy to system. So what will happen to that energy for the block? What will happen to that energy for the block? Is it converted into only increase in kinetic energy, or it is lost anywhere? That is what we are going to look after here. So what is the problem here? Rather than mathematics, what happened? You should be very good in terms of what? In terms of the observation, means energy from what form to what form it is getting converted. How that energy is available, and to in what all form it got available in the system. So here I'm bringing word one, mechanical energy here. What do you mean by that? Because very frequently I'll be using mechanical work. Means like a now the person does mechanical work, we say. So the person pushing the block means the person is doing mechanical work. So what do you mean mechanical? The block undergoes displacement. Now what actually happens for me? So when I push the block, there'll be displacement of my muscles. So now the energy stored, the chemical energy stored in the muscles, what happened? That energy, what happened, will get converted into the kinetic energy of the block. Got the idea now? This is like, so therefore in general, we just say I did mechanical work. So what I did, I converted my energy stored in my muscles into some mechanical energy. And what is mechanical energy? The kinetic energy of the block. The gravitational potential energy, elastic potential energy of spring, all they will become, they're called as a mechanical energy of the system. Mechanical means one which is available in the mechanical form, means due to some mechanics it is available. Due to some mechanics means due to some changes I brought in the system as I start pushing the block. Some mechanical change